The first part of the water plant project. This time it's a big project. A 15 cubic meters per hour dual-stage reverse osmosis device. The daily water production is about 240 tons. The water is mainly used for food processing throughout the industrial park. More importantly, its pretreatment tank and water tank are made of stainless steel. Because of the pretreatment tank we usually see are mostly made of fiberglass and resin wrapped around, only in hospitals or biomedical laboratories that this kind of old stainless steel equipment is used. The final point is the sealed and sterile water tank. I'll show you tomorrow. Today's work is to install these two sets of water supply pumps installed and measure the site at the same time. Tomorrow, we will see how to place the equipment. Although there are drawings, but there are still some differences between the drawings and the site. Every time I go out to work, I don't bring all the tools for these heavy things. Sometimes if you can't hire a forklift, we have to move them down by ourselves. It's time to show our true skills. The forklift you see now is brought by ourselves, but the height it can lift is only a little bit. It can reach the back of the pickup truck. So, we found a wooden frame to move it down, 2 pumps, and then at the base, about 5 or 600 caddies. 3 people push and pull, and 1 person protects the rack. This is also the power of the team. The pump we are carrying is a water supply pump, which is produced by the water inlet tank. Through this set of water supply pumps, it is supplied to each water point. His current location is near the sterile water tank. With the experience of the first set, the second set is easier to handle. But there is still one thing that cannot be avoided. The equipment is too heavy. We still have to take it slow. This set is the original water pump. The water from the original water tank goes through this pump, and then enters the back set of equipment. So its position is close to the original water tank. Site measurement. Problem 1. The diameter of our sterile water tank is 2.5 meters, and about 3.8 meters high. We measured the ground first. After adding the drainage ditch, the position is just enough for 2.5 meters. So, the position needs to be moved outward a little bit. Problem 2. The distance from the top exhaust pipe to the ground is 3.9 meters. Our sterile water tank is 3.8 meters. Then add a water inlet. Such a distance is more troublesome. Problem 3. The widest distance of its 2 entrances. The widest distance is 2.4 meters. We will have to demolish the wall to fit the water tank in. Here comes the opportunity to learn again. This engineer just crawled into other people's schools to see how their internal structure is arranged. This water tank is composed of 2 parts. One is the original water tank, and the other is a clean water tank. Why is there an additional water tank? In fact, the purified water is used to cool the equipment, and the raw water tank is used for food processing. So here's the basic question. Let's see how to solve it tomorrow. Okay, that's all for now. See you tomorrow.